Hey everybody, this is Ryan McNickle, and my presentation is about graphic reconstructions for quasi-experimental research. So basically, first thing that's important to understand is what quasi-experimental research is. And all it is whenever a teacher decides that something that they're doing isn't really cutting it, isn't really up to par, and they decide that they want to try something new, a new idea, a better way to teach a topic, a better activity or something that they're going to do, a new approach in any way, they're going to be conducting quasi-experimental research because they understand that what they're currently doing isn't good enough or isn't getting the desired results, so they want to try something new. They want to try a new approach that, in their mind, is going to produce better results. Obviously, if as teachers, if we're trying something new, we think this might produce something better. This might get the kids to understand it. It might get them to score higher on a test, or get them to be able to complete this assignment in a better way, write a better paper, whatever you're trying to do. So that kind of research, that data that you're going to gather, is quasi-experimental research. You're trying to see if this new idea or new method actually does produce the better results. So it's important as teachers to have to be able to kind of explain in a graphic way, in a detailed way, all the steps that we take in doing our quasi-experimental research for a couple of reasons. First, we want to be able to provide guidance to other people who might want to do the same thing that we did, especially if we're successful. We want to be able to kind of provide insights into the process and see if we were unsuccessful, where did we mess up and what can we change to be more successful in the future. And we want to make the program or our new method really clear to the people who are involved. The text used an interesting example that I liked, a metaphor for Columbus, and made the argument that Columbus was conducting quasi-experimental research because he had an idea that it would be a whole lot quicker to get to Asia by going westward across the Atlantic Ocean rather than sailing around Africa and through the Indian Ocean like everyone else at his time had done. So he had a new idea, something that he thought would be better, would produce a better result, and so he tested that out by traveling westward across the Atlantic. And it even talked about these three different areas, so in the providing guidance to others who may follow. Obviously, in Columbus's case, he wanted to be able to show future explorers and future seafarers, if he was successful, where he ended up getting. He wanted to kind of be able to look at the entire process to provide insight that might assist him in the future, might help other people in the future. Kind of the whole process. Where did he travel? What time of the year did he leave? What would he have done differently in the future? And then obviously he wanted to make sure that the benefactors are happy, make sure that the King and Queen of Spain are happy with him, so he wants to kind of keep them in the loop and fund his future expeditions, which of course they did. So it was a cool metaphor that kind of fit into what quasi-experimental research is. So those three reasons kind of in more detail kind of show us why we want to have graphic reconstructions of our research. The first one is to provide guidance to others. So if we're successful in whatever we're doing, meaning our hypothesis or our new idea worked and we did get better results, the kids learned better, the kids could write an essay better, they scored better on a test, they understood a concept better, then we want to really have a way that we can show others exactly what we did so that other people could follow in our footsteps. We don't want to be really successful in doing something and not have a way for others to copy it, especially if you teach other teachers who teach the same grade level or subject as you. You want them to be able to do the same stuff that you did, that you were successful at. Another reason why we want to have graphic reconstructions is if we're not successful, it's likely that there's just a couple of things that we could change to make ourselves be successful. It would be highly unlikely that our new idea was a total failure and wouldn't be successful at all. Obviously, if we're trying a new teaching method, it's coming from somewhere, so there's going to be some benefits to it. But if we're not super successful right away, it's really probable that just one or more small things are out of whack rather than the whole thing being a huge mess. So again, it's important to really have a a solid grasp of exactly what we did and kind of map out all of our steps, so we can see, what should we change, or what little thing could we adjust to make this work more effectively. And this could be in, a way that you're teaching your kids to write an essay, or the way that you structure a gifted program. So it doesn't necessarily have to be a new teaching method, but it's important to see what the whole process was, to see what we could change and adjust to be more successful in the future. And we want to be able to make whatever we're doing clear to everyone who's involved. So teachers, parents, students, administrators, everyone who's involved in whatever we're doing, we want it to be very clear to them what we're doing. So we want them to be able to kind of see, and again, that's why graphic reconstruction is beneficial. We want them to be able to see exactly what we've done so they can understand it and hopefully buy in and be invested in what we're trying to change and what we're trying to do differently. And it's important for them to have a clear picture of what's going on, especially students and parents. If we're trying some sort of new teaching method, we want it to be really clear to them exactly what we want them to do. If we're starting a brand new program at a school that's going to have different aspects to it, we want to map that out and have people be really clear in their understanding of what's going on. So all those are areas that a graphic reconstruction can help. And that's kind of what I just mentioned. So for all those reasons I just listed, it's important to be able to really clearly articulate our ideas, and using graphic reconstructions is really helpful with that. So this could manifest itself in a lot of different ways. The text shows a kind of a flow chart that was shown to students of Sager to kind of show how to do action research in a graduate class on action research, and it has a whole different stages and different steps over on page 77. But this didn't necessarily have to be a flow chart for a program for how to do something. It could be a representation for how you want a student to solve a math problem, how to learn a math problem in a different way. It could be a way you want students to write an essay differently, and different steps you want to have in there. It could be the kind of the meat behind a new gifted program and the different things that are going to be part of that, and the different aspects of it that you're trying to pitch to administrators or faculty or parents or a school board. So it doesn't necessarily have to be a flowchart that's in the book. It could be something that is more specific to a teacher. So these are just some examples of possible graphic reconstructions. The one on the left I found is just a sample from a high school showing different middle school and high school from different levels of math classes that a student might take, depending on their level or depending on if they get into a AP class later on or honors class, whatever it is. So that could be a really good graphic reconstruction if you're trying to put together some kind of program to show where students would kind of be headed. You could show that to students, you could show that to obviously administration, other teachers, and you could kind of see parents. You could see kind of what's going to be happening in the future if that's your idea for a program. The one on the upper right there, it's kind of blurry, but it's just a way to add and subtract fractions. So again, if you're trying to teach this as a new method to your kids, or if you're trying to pitch this to other teachers at your school, this would be a really clear, concise way to do it. And if there was some problem with it, or if there's a problem with the math classes, it'd be really easy to tweak one thing. If you had this in front of you, you see, oh, I see what the error was. It was there. I see. In 10th grade we had this issue, so we'll change that. So having these is really important. The bottom right there is just an example of a way to write an essay, a graphic representation of that. So again, all of these are important to have, because anytime we're trying something new, a new idea, a new method, a new approach, it's important to have a really clear, concise, specific list of steps that we're going to take to hopefully be successful, for all the reasons I just mentioned. Because we want to be able to guide others in the future if we are successful. If this method for writing this essay is really successful, we want all the teachers to be able to do it, and this is be a clear, concise way to show them that. If we're unsuccessful, if we are trying to schedule math classes for a large group of kids and we fail, and there's a mistake in 10th grade because something strange happens, we can adjust something. We can see the entire graphic representation of that. We can adjust something rather than saying, this program is not going to work, we'll throw it out. And we want to be able to make it clear to everyone involved. So if we're trying to teach a new method to add and subtract fractions, and parents don't understand how to do it, they might struggle helping their kids with their homework. If we're trying to pitch this as a new idea to the faculty, and they don't understand how to do it, or they're not clear on how they're going to teach their students, then it's not going to be successful. So having this graphic reconstruction is going to be good for that too. So that leads us to our discussion questions. Why is it important to have graphic reconstructions of quasi-experimental data? And then how could you use a graphic reconstruction in your classroom or your setting? Thanks, everybody.